Okay, so in this video, we will talk about suffix arrays. And this is a data structure you can use during string processing. There are prefix trees or tries, suffix trees, and suffix arrays that can all be used in many different real-world applications. Well, except for the try, it isn't really used in the real world because it consumes way too much space. A suffix tree is a lot lighter in terms of the amount of space it consumes and much faster than a try. And it can be used to maybe index DNA or optimize some large web search engines. A suffix array is like a stripped down data structure that is based on the suffix tree. It takes up far less space and can be a little slower in some pattern searches, but generally used more than a suffix tree. The biggest things to be aware of and the differences here are space used and the time for completion. So to put this in perspective, to index the DNA of a single human being, it would require about 40 gigabytes of memory. So let's talk about what a suffix is first. A suffix is a substring at the end of a string of characters. If we take the word Mississippi, we start with the last letter I. The suffix usually relates to something after, right? So we will start at the end of the string and then work back to the beginning, taking I first as our first suffix, and then PI for the next suffix. And you keep adding on a letter until you return to the beginning of the original word. For our purposes in this tutorial, we will say suffixes are non-empty. But when you get a question relating to suffix arrays, it should be asked to your interviewer, hey, if there will be any non-empty suffixes. Now we can answer the question, what is a suffix array? A suffix array, or SA, is an array which contains all of the sorted suffixes of a string. Now the order in which it is sorted in alphabetical or lexicographical, same thing. And so we look at our slide. We first get all the suffixes of the word, let's say blogger. Then we sort them alphabetically to create an array. You can see there is a value next to each suffix there on the right side. And this is just the index of the suffix. And of course, we start at the 0th index. The 0th index is usually the original string used to obtain the suffixes. Now, looking at the right side here, we can see the numbers aren't in order. It remains as the original index. So because originally ER was at index 5 from the beginning, so index 5 here, it started at index 5. Here, because it falls alphabetically first in comparison to all the other suffixes, we actually move it to that index there. If you look at the next two suffixes, you will see that both of them contain G as the first letter. All we have to do is move to the next letter to alphabetize it. So E comes before G, and therefore we have it alphabetized. The one thing to note here is that the suffix array includes the sorted indices. In this example, we start with the original word in the 0 index, ER, which was at the index of 5, then index 4, and so on. And this provides a compressed representation of the sorted suffixes without having to store them. Now let's pull a hard question from LeetCode. Given a string S, return the last substring of S in lexicographical order. Remember, lexicographical is the same as alphabetical. So here's our string. We got a string here with letters and numbers. The size of the suffix array is equal to the length of the string. So we have a 26 character string here, and that means that we're going to have 26 elements within our array. And below is just the list of the 26 suffixes, but it is not in alphabetical order yet. So let's get some code written to create a suffix array. First, we're going to generate an array with suffix pairs and the suffix string and its number. So to do this, let's call this array suffixes. Oh, and we're not going to forget here that they are string S. All right, here we can make a nice list comprehension. So we'll use S, and we'll index this with I, colon, right here. Now say for I in the range, the length of S. We're going to do this 26 times. The next thing we're going to do is we're going to sort this list by the suffix string. So suffixes here, we're going to sort using, here we'll do a key of lambda, where x to, let's say, x in the 0th index there. All right, to satisfy our solution, don't forget the question. The question said, given a string S, return the last substring of S in lexicographical order. So we want that last element within that array. So let's go ahead and print that out. We'll do print suffixes. Now, keep in mind that that sort method does sort suffixes in place. So we can say, let's just pop that last element off of suffixes. To visualize this execution, we start with loading in that variable S, our string. Here's our list comprehension now. All right, so our list comprehension will load up all of these I's. We're talking about 26 characters here. After it's loaded in, we get a nice sorted array here. All right, because we're using sort here. So we get that nice sorted array where each one of these are an element. So we start with the first element. Oh, we haven't sorted it yet. So let's start with this. Here we go. Now we're starting with the sort method here. So we're starting to sort this out. All right, by the way, this is also a tim sort. So sort is a native method to Python using tim sort and is pretty efficient. All right, we're left with our array, everything in alphabetical order. As we can see, alphabetized array with each suffix in it, making it a suffix array. And then finally, our last line of code here, code number 6, or line number 6, print out that last suffix. And it originally started with index 2 here. This will be fine when you have, let's say, a character string, probably less than 100,000. But if you did have a character string that was 100,000 in length, then if you use this method, you'd probably waiting around for a little while and use a lot of memory. So you can use some sort algorithms to sort to improve the time complexity and efficiency. And another thing to note is that integers are faster than strings when calculating. So when it comes to calculations, you could also convert to integers to improve its speed. And there's also a module named suffix array in Python, of course. But in this example, we will just use some native code and get the results. So to conclude, a suffix array provides a space-efficient alternative to a suffix tree, which is a compressed version of the trie. Suffix arrays can do just about everything suffix trees can do, with just some additional info included. All right, and one last thing to note is this is a tim sort, so it does have sort of it does utilize an efficient method. However, you can speed this up and make it perform better on sort of large strings. Something also to keep in mind. All right. Well, I hope you guys got a good understanding of what a suffix array is, what suffixes are, and how to use some native Python to construct a suffix array. All right. Thank you.